This video is going to look at the objective number 2 from 4.3, which is finding trig functions given two pieces of information about other trig functions. As you can see by the title of the slide, it's an example where we're given one trig ratio to find the others. So that's the key in this case. Now, in this case, ultimately, all it's asking me to find is sine and cosine. So in the end, I need sine of theta equal to something and cosine of theta equal to something. Now, hopefully, we are thinking as soon as we need sine and cosine, we're thinking sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, which really just means if I have a triangle, I will be able to find these pretty quickly and easily. Now, in the last example, or objective 1, we were giving an ordered pair, so we would just find that point in the coordinate grid, and that would tell us what quadrant it is. The key for these types of situations is they're going to give you information about a trig function. So for example, in this case, it says that tangent of theta is 4/3. Well, since there's no negative sign, that means it's positive 4/3, which means tangent is positive. So for these types of problems, the first thing you're going to do is figure out which quadrant is the triangle going to be in. So step 1 is finding the quadrant. Now, in order to do that, I need to remember which quadrant tangent is positive in. The problem is that happens twice. I know tangent is positive in quadrant 1 and tangent is positive in quadrant 3. So one trig ratio alone is not enough to give me enough information to be able to figure out the quadrant. I can eliminate quadrants 2 and 4 though. That's why they're going to give me this second piece of information. It says that the cosine of theta is less than 0, which means that the cosine of theta is negative. So when I think about quadrants 1 and 3, I know that it's quadrant 3 where cosine is negative, therefore that's where my triangle needs to be. So no longer is it in quadrant 1. Once you determine your quadrant, the second step is to draw your triangle in that quadrant. Draw a triangle in that quadrant. Now, as we talked about in the previous example, you need to draw the terminal side of your angle, so from the origin out somewhere in that quadrant. And the most important piece is to always make sure you connect that triangle to the x-axis. Once again, as we've been talking about, we're going to use that reference angle as theta, so my triangle should look like this. Now, once you have your triangle, label the parts using the trig ratio given. So we're going to use the ratio given. Having said that, they said that the tangent of theta is 4/3. We know tangent is adjacent. That's not true. Tangent is opposite over adjacent. So we're going to say that the opposite side is 4, the adjacent side is 3. Now, once I have the sides labeled, then I go back and figure out my positives and negatives. Since I'm going this direction, that's a -3, and I'm going down, so it's a -4. Once I know two legs of the right triangle, now again, like we talked about on the previous example, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared, where my legs are -3 squared, my other leg is -4 squared equals c squared, 9 plus 16 equals c squared, 25 equals c squared, and so c equals 5. Now, some of you may have been able to do this example without doing the Pythagorean theorem, and maybe you remembered that there is such a thing as a 3, 4, 5 right triangle. But if in doubt, go ahead and use the Pythagorean theorem. Now that I have my triangle labeled, I can go back over here. Ultimately, I need to define the sine. Sorry about that again. I need to define the sine of it. Well, that's the opposite, which is -4, over my hypotenuse, which is 5. And remember, your hypotenuse will always be positive when you do these. And for cosine, the adjacent was -3, and the hypotenuse is 5. So these would be my answers for this one. Okay, so that is the second objective. We're going to do one more example that I'm going to give to you, and I'm going to give you a few minutes to try to set up on your own, and then we'll go over it. So the last example we're going to do today is actually number 43 from your homework assignment. So go ahead and get this one written down. You're going to find sine and tangent if cosine is positive 2/3 and the cotangent of theta has to be greater than 0. Give you a minute and a half to try to set it up. Okay, so if you believe you're on the right track, keep working. For anyone who's stuck, let's figure out the quadrant. Again, I'm given cosine of theta is positive 2/3. I know that cosine in the unit circle is my x value because the ordered pairs are cosine sine, which means that cosine is positive in quadrants 1 and quadrants 4. So I know my triangles won't be over here. Again, that alone isn't enough information to help me, so now I have to go to the second piece, and they say cotangent of theta is greater than 0, which means cotangent is positive. Now, when we do unit circle stuff, we don't really talk about cotangent, but I know that it's the reciprocal of the tangent function, and so therefore, if tangent is positive, cotangent is positive as well, and of these two quadrants, tangent is positive in quadrant 1. So it's going to be quadrant 1. Once I establish my quadrant, I draw my terminal side of a triangle there, connected to the x-axis, label the reference angle as theta, and then I know cosine is adjacent, so the adjacent side to that angle is 2 over hypotenuse, so my hypotenuse is 3. Once we've labeled our sides of the triangle, then hopefully again you're thinking Pythagorean theorem. A squared plus b squared equals c squared. Again, the difference with this problem is that I'm given a leg and a hypotenuse, so just be careful with that. One leg is 2. I'm going to find the other leg, and my hypotenuse is 3. So I get 4 plus b squared equals 9. Subtract 4, b squared equals 5. So b equals the square root of 5. Again, this time, technically it could be equal to plus or minus, because we said if it's a hypotenuse, we'll always take the positive. If it's a leg of the triangle, you need to pick the sign that matches where it is. And in the first quadrant, I'm going up, so this is a positive square root of 5. So again, you need to match the sign, the positive or negative, to where it falls in the quadrant. And now that I have that, it wants me to find sine of theta and tangent of theta. So I'll give you 30 seconds to figure that out. Okay, so again, we know sine is opposite over hypotenuse. My opposites either side across from the theta was the square root 5, and the hypotenuse was the 3. So you can label them. The 2 would be the adjacent then. Tangent is the OA, so opposite, which is square root 5, over adjacent, which is 2. So the tangent and my sine give me these final answers. So again, both those examples are from Objective 2, and basically you'd be given a trig ratio and another trig function. You'd find out if it was positive or negative. First, you need to figure out what quadrant your triangle goes in. Second, you draw the triangle with the terminal side from the origin to some point in that quadrant and connect it to the x-axis. Label the sides of the triangle based on the trig function given, and then find the missing side by using the Pythagorean theorem. You should be ready to practice now. Your homework is section 4.3, page 381. You can look up the PDF of the book on Moodle. Your homework assignment is numbers 3 through 24, multiples of 3, 43 through 49, odd, 59, 68, and 70. You have the rest of the hour to work.